Okay, so today we're going to focus on polynomials. We're going to talk about what they are and the different types. We're going to look at the degrees of polynomials. We're going to do arithmetic for polynomials, including addition, subtraction, multiplication, and division. And then finally, we're going to do a couple of word problems for this topic. So generally, when we're thinking of a polynomial, I want you to think of it as a bunch of terms that are related to each other through addition, subtraction, multiplication, or division. And by terms, I mean things that have constants and variables. Examples of some terms are x. This is a term. And then you can have something like 2y squared. 2y squared as a whole is a term as well. And then even constants, regular numbers like 3 and 4, those are also terms. And then another example of a term is like something that has a coefficient and then different variables. So it doesn't always have to be x alone or y alone. It could be xy, or it could even be xy squared, like in the case of this. So these are examples of some terms. So a polynomial is when you see a bunch of constants and a bunch of terms combining with each other using these arithmetic methods of plus, minus, times, and division, or sometimes you just see a term all on its own. That brings me to over here. So an example of a term on its own is 2x. So 2x on its own, we would call that a monomial because it's basically a polynomial with only one term. There isn't anything else. It's just this for that. And then you could also have a binomial term, which has two different terms that are unlike each other. So first term is 2x, and then it's adding with 3. So you have two terms, so that's a binomial. And then you could also have a trinomial, which is a polynomial that has 3 terms. So an example of that would be 2x plus x squared plus 3z. So these are 3 different terms related to each other using the addition function. And then sometimes you will have a term that has more than 3, so it's not really a trinomial. It could have 4 terms, 5 terms, 6 terms. An example would be the 2x plus 2x squared plus 3z plus 2. This is 4 terms, so once it goes beyond 3, we just call them polynomials going forward. But all of these are types of polynomials because they have terms that are kind of in a type of expression or equation. So in a typical polynomial, we can determine the degree of the polynomial by finding out what the largest power is. So an example of that is if I have a monomial term like 6x cubed, the degree of that would be 3 because the power of x, which is the variable here, is 3. So, and there isn't any other term, so by default, it is the largest term. So in that case, our degree would be 3. But if I have a binomial term like 5y to the power of 8 plus 6x to the power of 3, then I would say that the degree of this polynomial would be 8 because we have 2 different terms. I have to look at the variable that has the largest power, and that in that case it's y because it has a power of 8. So because of that power of 8, it's going to be a degree of 8 for this polynomial term overall. And then if I was to move downwards to this trinomial where it's 2x to the power of 7, y to the power of 4, and then you have 5y to the power of 8 plus 6x cubed, then in this case, you might be tempted to say the degree of the polynomial is 8, but it wouldn't be in this case. And the reason why is because if we were to look at 2x to the power of 7, y to the power of 4, we can basically say that these two variables, their powers combine with each other to give you like the overall degree of the polynomial. So in this case, x has a power of 7, y has a power of 4, so everything will add together, and the degree for this polynomial will be 11. And 11 definitely supersedes the power of 8 from this term over here and the power of 3 from this term over here. So for this trinomial expression, your degree will be 11. And then going into the next concept, if you have a constant, something that is just 2 on its own, you can basically say 2 is the same thing as 2x to the power of 0. And the reason why is because anything to the power of 0 is going to be 1. So if I say I have a term that's just 2, then you can say that the degree of the polynomial in this case is 0, because you can imagine that you have 2x to the power of 0 there, and of course the power of x is 0, so the degree will be 0. Now, if I want to do an addition or a subtraction of a polynomial, the main thing I'm going to want to do is combine the terms that are alike. So, for example, if I have 2x plus 5x, these two terms can combine with each other because they both have x to the powers of 1, or just regular x's. So these, because of the terms being so similar, you can just add the coefficients together and then keep the x. So what we would end up doing is we would add 2 plus 5, that will give us 7, and the x will remain. Another case where you have like terms is if you have 3y to the power of 2 plus 5y to the power of 2. You're going to notice that both of them are y to the powers of 2. So you could just add the coefficients of 3 and 5 together, and then you would get 8y to the power of 2. But then if we have cases where there are unlike terms, like in this example here, when you have 2x plus 3y to the power of 2, then because you have x as the variable here, and then the variable here is a y, which is a completely different letter, and then it's even powered to 2, these two are unlike, so they would not add together. So that's why we would just write the same thing on the product side. And then the same thing goes for if you're doing a subtraction. If I have 5x minus 2x, these two things can combine with each other safely because they both are x numbers. They both have x as the variable. So you could just do 5 minus 2, that's 3, and then x will remain in the product side as well. And then if you wanted to do 5y squared minus 3y squared, we should be safe to do this because both of these are y squared numbers, so they are alike. So you can do 5 minus 3, that will give you 2. The y square will also be there on the other side of the equals to sign. But then if you have 3y squared minus z, well, there isn't really anything that is closely related between these two because the variable letter here is y, the variable letter here is z. So there is no relationship, so they will not go through with any like subtraction. Now, bringing that to a particular scenario, let's say we have we have two trinomials adding together. In this case, I wanted to add 8x squared plus 6y plus 1, and that's in addition to another trinomial, 2x squared plus y plus 4. If I wanted to open up this expression, I would want to get rid of the like the brackets on either side. So if I want to get rid of the bracket, I have to first of all recognize the sign that is in front of the values in the parentheses. So I put a little positive sign over here to represent the fact that there isn't any negativity in front of the first polynomial, and there's also a plus sign in front of the second polynomial. So if there's a plus sign in front of the polynomial, the signs on the inside will not change. So we can just open this up as usual. So that's how we'll end up with 8x squared plus 6y plus 1 plus 2x squared plus y plus 4. So nothing inside changed signs. So one thing that my student did that I really like that I'm going to talk to you guys about is that in order for you guys to keep all your like terms straight, you can assign different shapes to them. Like all the x squared values, I just circled it, and then the y values I squared, I put a square on it, and then the constants, which are basically x to the power of 0 numbers, I put a triangle on them. So if I add these two things together, I can get 8x squared plus 2x squared. That's how I got 10x squared. Then the things in the squares, 6y plus y, I got 7y. And then the things in the triangle, 1 plus 4, that gave me 5. So that's how I ended up with my answer over here. And then in the case of subtraction, I can do the same trinomials, but then this time it's a subtraction sign in between. If there is a minus sign in front of something in parentheses, everything inside will change sign. Let's say that you have a minus sign and then what was inside was a positive, then it will become a negative. If it was a negative inside, then it will become a positive. So if we're to bring that into play, when I open up the bracket, I will get 8x squared plus 6y plus 1 because that's fine because there's a positive sign. It's positive. There's no negative sign in front of the first one. But then when I'm opening up the parentheses on the second one, I have to change all the signs inside. So it's going to be minus 2x squared minus y minus 4 because all the signs inside were positive. So again, I'll circle my like terms and put different shapes. I'll basically assign different shapes to my different like terms so I can move ahead with the arithmetic. So if I do 8x squared minus 2x squared, I'll get 6x squared, 6y minus y, 5y. And then if I do 1 minus 4, that's how I got minus 3. Now, if I wanted to do multiplication and division, then it's a whole different ballgame. Let's say that I have a templates reaction or templates multiplication going on. I have ax to the power of n multiplied by bx to the power of m. These two things are x terms, and a is a coefficient, same as b. So a can either be 1, 2, 3, 4, etc. Same for b. So these are just numbers that represent the coefficients of the term. And then the variables are the same as x. And then I have two different power numbers. So n in the case of the a one and then m in the case of the b one. If I wanted to multiply these two expressions, I would basically end up getting ab because the coefficients will multiply with each other. And then the terms are the same, so it's x. But then if I'm multiplying, I'm going to do n plus m for the powers to get the new power of the value. So an example of this is if I had 2x squared multiplying with 3x, then I would basically do the two numbers in front multiplying each other. So that's going to be 2 times 3. And then the x is going to be there. And then the new power of x will be the sum of the previous powers, so 2 plus 1. So my value will end up being 6x to the power of 3. But then if I have two different variables, then we're going to treat it differently. If I have axn multiplied by bym, then x and y are not the same variables, so you're going to treat it differently. You're still going to multiply the coefficients with each other, so you're going to get ab, but then you cannot safely, multiply the x and the y together. So you're just going to carry over what you had before to the other side. So x to the power of n, you're going to see x to the power of n. Y to the power of m, you're going to see y to the power of m. So an example of that is if I have 2x squared multiplied by 3y, then I will end up getting 6x squared y. So 2 times 3 multiplied, but then the x squared and the y cannot multiply with each other, so they're just going to be beside each other. Okay, now let's talk about situations where we can use distributive law for polynomials. If I have 2x and then it's multiplying 3x plus 4, then we can say that the 2x distributes to multiply with all the terms inside the parentheses. So 2x will multiply by 3x and 2x will also multiply by 4. So if I was to bring that down, I will end up seeing that it's going to be 2x times 3x plus, because we're keeping the same sign that was between these terms, plus 2x times 4. Everything will be equals to 6x squared plus 8x. Then going over to division, if I have axm and then it's dividing by bxn, remember a and b are your coefficients, x are your variables, and then you have m and n being your different powers for the different variables. Your value will end up being a divided by b. The coefficients will divide each other, and then for the exponents of the x is going to subtract. Remember when we were doing multiplication, it was adding. In this case, it's going to subtract. An example of this is if I have 15x to the power of 6 divided by 3x to the power of 3, then to get my answer, I will get 15 divided by 3, and then you have x, 6 minus 3. Remember the format we're using. So my answer here will be 5x to the power of 3. Another example is if I have 15x squared minus 20x divided by 5x, then if I wanted to do this arithmetic, I can just break down this fraction into halves. So the denominator will still be 5x, but then instead of having it all together, I can have 15x to the power of 2 divided by 5x and minus 20x divided by 5x. So everything is still 5x in the denominator, but this just helps us do this breakdown very easy. So again, we'll follow our rule for dividing. 15 divided by 5, you get a 3. X squared divided by x, that's going to be the same thing as x to the power of 2 minus 1. So that's how we got x over here, so 3x. And then if I have 20x divided by 5x, then it's going to be 20 divided by 5, you get 4. And then for your x, you have the x's canceling out. So that's how we got 3x minus 4. Minus because there was a minus before. Another scenario we have is if we have 18k squared minus 9k divided by minus 9k. So we can basically split the addition once again. So you have 18k squared divided by minus 9k divided by minus 9k. That was a bit of a mouthful. But yes, you would end up doing 18 divided by minus 9. You get a minus 2. K squared divided by k is the same thing as k2 minus 1. And so that's how we got k over here. So it's minus 2k for this part of the equation. Another scenario is if you have minus 9k divided by minus 9k. Everything cancels out. Minus 9 divided by minus 9, that's a 1. K divided by k, that's the same thing as k to the power of 1 minus 1. So it's k0, so that's basically 1 times 1. So that's how we got minus 2k plus 1. Okay, so now let's look at some real world scenarios / word problems. So for my first question, I have a surveyor that is measuring a plot of land and then finds that the width of the land can be expressed as 5x. He then finds out that the length of the land is 5 more than the width. I can represent that plot of land as a rectangle here, where my width is 5x, and again, my length is 5 more than the width, so it would be 5 plus 5x meters. They asked us to find out the perimeter. So how would we do that? The perimeter is the sum of all the sides of the shape. So it would be the sum of this part of the width and then this part of the width and then the sum of the two lengths. So it would basically be 2 times the width plus 2 times the length. So that's what we have here. You have 2 times 5x plus 2 times 5 plus 5x. If we want to get the answer to this expression, we first of all have to handle the multiplications. So 2 times 5x, so the two coefficients will multiply 2 and 5. You will get 10, and then the x will be still x in the answer because there wasn't any variable for the constant of 2 over here. So that's how I got 10x. And then if I want to do 2 times 5 plus 5x, I have to reflect back on my distributive law. And based on my distributive law, I know that 2 will have to multiply with 5. And the same 2 at the front will also have to multiply with 5x. So if I do 2 times 5, I will get 10. And then if I do 2 times 5x, well, we've already done that in this situation, so we will get 10x. So if I add 10x and 10x, which are like terms, then I will get 20x, and then that will be plus 10. So we will get a binomial expression of 20x plus 10 meters. This is a perimeter, so there's no multiplication, so your answer will still be in meters. We're just adding all the sides together. Then, if I want to find out the area of this plot of land, I can say that my area is equals to the length of the shape times the width of the shape. So that means that I would multiply 5 plus 5x by 5x. 5 plus 5x is again our length. The width is 5x. Both of these can be measured in meters. So that's why I put a meter over here and a meter over here. So both these lengths are measured in meters. If I were to do my multiplication again, I would do distributive law where 5x multiplies with 5 and the same 5x multiplies with 5x. So that's how I got my area of 25x from 5x times 5 and then plus 25x squared from 5x multiplying by 5x. And so it will be 25x plus 25x squared, and then it will be meters squared. Sorry, I will correct that. It is meant to be meters squared as your answer. And then another real world scenario that we can often deal with is billing. So a lot of phone companies could apply to this case. So if I have an imaginary company called Fast Mobile, and it's a phone company that charges a base monthly rate of $220 to all of its users, in addition to an additional charge of $2 for every international call made, then if they want us to represent the total monthly charge for this equation, then we can basically say that the total monthly charge is, of course, your base rates of $220 plus $2 for every international call made. So I'm going to represent the number of international calls made as X, which is a variable because it could be any number. It could be a 1, 2, 3, or 4. So if I wanted to represent everything as an equation, it would be 220 plus 2X. 2 came from the cost per international call, which we are representing the number of international calls made as a variable X. Okay, and so question B is, what would be the total monthly charge if a user makes 4 international calls in a month? Well, in this case, the number of international calls made is 4, so X will be equals to 4. So we can just plug that into the algebraic expression we made in question A, and I can just do 220 plus 2 times 4. It would be 220 plus 8. So overall, this user would be charged $228.